Hey everyone, welcome back to the second session of the Flare Hackathon. Today we'll be joined for the second workshop by Nik, which is the first of his series of three. He'll be giving the first of his three talks on the Flare data connector. I'll invite him to the stage now and I'll keep on giving you some information. So he'll be giving a better introduction to his talk when I hand over to him in a moment. But first of all, I'll make sure to remind everyone here about the previous Flare Educate sessions. Make sure that you've all caught up with them if you've not been aware of them already. I'll add a link to them in chat as I speak. And so yeah, you can follow this to find out or catch up on any missed sessions of the Flare Educate which just preceded the hackathon. And so yeah, as for general hackathon questions, I'll always direct you to the dedicated Discord channels in the Encode server. And you can always reach out to me on Discord there.
Cool, thank you, Patrick. So hi from my side as well. My name is Nik Erzetič. I'm a DevRel at Flare. And today we'll be leading the workshop on the Flare data connector, connecting and using Web2 APIs in your dApps. So this is the first of three workshops that I will be having. This one focuses on the JSON API FDC attestation type. Basically, this is an attestation type that allows you to bring an arbitrary Web2 data onto the Flare chain. And it is, in this sense, the most general of the Flare attestation types. So the way this workshop is gonna go is I will walk you through the official Flare starter package for Hardhat, which can serve as a template for you to start building. This code that you will see today is basically ready to go as is. So if you have any questions, ask them in chat. I'll try to respond as I see them, but if I miss them, I'll answer them at the end of the session. So this workshop is planned to go for 45 minutes, and then there will be time for questions afterwards. So yeah, let's just get started with, first of all, if you go to Flare Hardhat starter on GitHub, this is the repository that I will be working with. I have already cloned the repository and followed all the instructions in the README file for setting it up. There is also a Foundry version of this starter kit, which is mostly the same. It is just missing the last feature, the one that I will be guiding you through on Monday. So there's also that. But before we continue, there's the third thing that I would like to show you, which is the Flare Developer Hub. So if I just type it in, the Flare Developer Hub has written guides on 4 out of 6 attestation types. There are also guides for Foundry there as well. So if you want to go through them on your own, this is the place. So Flare Developer Hub, FDC, and then Hardhat or Foundry guides, depending on which ones you want. Well, first of all, this is the repo, Flare Hardhat starter. As I've said, I've cloned it and went through all the steps described in the README file. Now, before we go through the code, I think it's important to first of all explain what we are trying to achieve with the JSON API attestation type that we are looking at today. So, first of all, let's say that we have a public-facing Web2 API, for example, the Star Wars API. This is basically a website that allows you to query characters of planets or starships. For example, if you post a GET request onto this link, so Star Wars API people/1, what you get back is Luke Skywalker and a few of his characteristics. Now, so this is the first component of this attestation request, is retrieving data from a public-facing API. Now, the second one, the second thing that this attestation type allows us to do is to put a JQ filter over it. So if I go to the JQ Playground website, for example, the first one here, and if I input the character of Luke Skywalker, the response that the Star Wars API will be returning under the JSON, now I'm able to filter the data that I get using JQ. So, for example, I can store the name of the character that I get under the name variable or under the field name. I can do the same with height and also mass. And why I do this will become clear later when we get further into the example. Another thing that I can do is get the number of films that Luke Skywalker appeared in. But if I just do films, what I get back is an array. So what I can do instead is pipe that output into the length function, which gives us back number 5. And one last thing is UID. This will be the character ID. So in this case, number 1, because we queried people/1. And to get that back, I first need to get the URL. I then need to split it over the /, which gives us a list. And then I can access the second to last element, which gives us number 1. But that is a string, so what I can do as well is just write to number, which actually gives us back the number 1. I can also apply these filters to the other two fields with integer values here. So let's just do that real quick. Okay, so these are the first two components of the attestation request. So the URL that we are getting the data from, or the public API that we are getting the data from, and the JQ filter that we are applying over it. It also has a third component, which I'll come to in just a bit. But with that, we can now look at the code for this example. So let me just close this real quick. So here we can see the Flare Hardhead starter package. If we go under contracts, we can see a very simple, so if we go under contracts and FDC example and click on JSON API, we can see a very, very simple contract that is able to interact with the data that we get from the Star Wars API, as well as validate the proof that this data is valid. So what this contract does is it takes the data about the Star Wars character, performs some minor calculations on the data, and then stores it as a Star Wars character struct. And this struct just has these 4 fields. So the name of the character, the number of movies it appears in, the API UID, which is the ID on the API source, number 1 in the case of Luke Skywalker, and then the BMI, which is the body mass index, which we can calculate quite easily. Here at the top of the file, you can also see a data transport object struct, and I'll come to that later. So what our contract does is it has the add character function, which basically receives the iJSON API.proof struct, which, let's look at that actually. If we go to under node modules and Flare network, Flare periphery contracts, and then custom 2, if we search for iJSON API here, we can see all the structs related to that. And here we can also see the proof struct, which is made out of a couple of things, but basically this is the solidity struct that carries the information, the data that we are requesting. Let's open the file back again. So the add character function receives the data and proof about our query. It validates the proof, and I'll talk about that in just a second. Then it decodes the data to the data transport object, and I'll get back to that in a second. And then if the character hasn't been added yet, it saves its their information to a Star Wars character struct, populating the fields with appropriate values and calculating the BMI by first converting the mass to, by dividing the mass by height squared, but in meters. This isn't that important actually. And then it adds the character to a mapping, which is a public mapping that, given the UID of the character, returns the Star Wars character struct. And it also adds the UID to the character IDs list or array, which is just a way to keep track of all the characters that have been registered so far. Now, as I've promised, first of all, let's talk about the data transport object. If you look at it closely, you can see that its components reflect the ones that we specified in the JQ playground. So we have name, height, mass, number of films, and UID, which is the same for the data transport object: name, height, mass, number of movies, and API UID. This is the solidity struct that we want our data to be encoded as. How we can specify it to the FDC, the Flare data connector, is a thing I'll leave for. I'll explain that in a second. The other thing that I promised that I will explain is how the contract is able to verify the data. It does so through a JSON API verification contract on Flare. Now, why do we access it in this way? Contract registry is a library that is shipped with the Flare periphery contracts. It's basically a library that gives us a clean way to access official Flare deployed contracts. What happens in the background is that there is a contract on Flare called address registry, which holds the registry. It has a mapping from contract names to the addresses that they are deployed at. So it also has a method that allows us to look for the address of a specified contract. But this is very error prone, just inputting the name of the contract we are trying to access. So instead, we are shipping the Flare periphery contracts package with this library that has quite a few functions that allow us to, first of all, autocomplete them in the editor and get the contract that we want in this neat way. The reason the keyword auxiliary is here is that the JSON iJSON API or JSON API attestation type is still in development. We will be getting rid of that auxiliary keyword once it's fully integrated into the Flare ecosystem. So basically what we do to verify the proof is get the JSON API verification contract and then call its verified JSON API function on our proof data. And that verifies the proof. How is the proof actually verified? For that, you can go and read the guides and documentation on the Developer Hub website. Now, the only mystery still remaining is how to get the third component, that is the solidity struct that we want to encode our data as, and how can we specify that to the FDC. And to do that, we are using a simple trick here. We are defining a ABI signature hack function that does nothing, but it receives the data transport object as one of its parameters. And now, what this allows us to do is to go look under the artifacts that are created by Hardhat, go under contracts, and FDC example, JSON API, and then the Star Wars character list. And if we search for the ABI signature hack, let's see. Okay, cool. Cool. I think that what I need to do right now is to just quickly run yarn hardhat clean and recompile the whole thing. Cool. Let's see. Perhaps it's one of the other structs. Okay, let's do it the old-fashioned way and just delete the artifacts like that. No, I don't think it's ABI_signature. What I'm actually looking for is ABI signature hack, the name of the function. I'd like to find the function here because I can then read the struct data from its parameter signature. Oh, I think I know what the problem is. Yeah, let's do that. That's very, very, very interesting. Well, anyways, let's not waste time on this. Basically, what should happen is that we should be able to find the ABI signature hack function, and listed as its only parameter would be the data transport object, and we could copy the ABI signature from there. And that would give us a way to notify the JSON, the FDC, what to store our data as. I don't know why it's not working. I'll try to debug that off camera. Anyways, what now remains to do is actually interact with the FDC. And to do that, let me first of all explain how what the FDC workflow actually looks like. So if we go to the Flare Developer Hub and click on FDC, and then if we scroll down to Workflow Overview and User Workflow, we have a handy diagram showing us what the workflow looks like. So first of all, we have some external data, in our case, the Star Wars API website, and we want to get the character data from them. We then need to create an ABI encoded request for the FDC. But how do we do that? We could do it manually, and the guides on the Developer Hub website actually go into that. But a simpler way to do it is through a verifier server. And all we have to do is create a request to that server with certain data that we want to get. In our case, that would be the URL, website, the URL, the JQ filter, and the ABI signature. We send this to the verifier with some additional things, and it will create the ABI encoded request for us. And then we can submit the ABI encoded request to the FDC protocol. We do it through a contract on the one of the Flare chains. And then we just have to wait for the current voting round to finalize, which takes no more than 180 seconds, but in practice, it's a lot quicker than that. That is the worst case scenario. And after the round has finalized, we can request proof and data from a DA layer provider, which then returns the proof and data to us. And we can then give this proof and data to a smart contract of ours, in our case, the Star Wars character list. And the contract then contacts the verification contract, verifies the proof, and does whatever it wants with the data. So this is the general workflow. Now let's look at the script that actually does this. Yeah, thank you, Anoy, for that. I'll look at that in a second. So yeah, let's open up the scripts and go to JSON API.TypeScript. First of all, if we look at the top of the file, we can see the three things that I've been mentioning the whole time. So the URL that we are trying to access, in this case, we'll be trying to access the data about the character number 3. Then there's the JQ filter, squashed to a single line. It is the same filter that we wrote. We just added some backslashes to escape the quote, double quote characters. And then there's the ABI signature that I was trying to find there. It's quite a long thing if you squash it to one line, though that is not actually strictly necessary. We could actually input the whole thing with the new line characters included, but let's not get into that right now. There are some additional things that I won't explain right now. They're just there to signal to the verifier what kind of request we are actually making. Let's just look at the main function right now. So we will first prepare the attestation request using the verifier server. Then we will submit it to the FDC contract. Then we will retrieve the data, deploy our Star Wars character list contract, and feed that data to that contract. So let's look at the functions real quick. So prepare attestation request. What it does, it creates the request body with the 3 values that we have prepared. It also prepares the URL that we will be posting the request to, and this is where the verifier URL base comes from. And then it feeds that to a base function that is the same for all attestation types, and we'll look at that as well. But let me first show you something else. I see your question. I'll answer that at the end of the presentation. Yeah, if we look at the example environment file, there are a few values that we should input. First of all, the private key, but just like Sinachi has asked in the chat, one other thing that we will potentially need is a JQ verifier API key, which, if I'm not mistaken, it could be that you can access it without a key, but you will just get rate limited if you post too many requests. But in case that that's not true, just ask in Discord or in the Telegram chat, and we will provide a key for you. So anyways, what I tried to show you here was the verifier URL. If we just open this one, and it opened in the correct window, which is great. If we append to it API doc, sorry, it's this one. So if we just append API doc to that, we get an interactive verifier where we can actually test our requests in advance, specifically the prepared attestation request. If we click try it out, it also shows us what the request looks like. That's how we know what data to input into the request body. And then the prepared attestation request base function, it takes the body and then it adds two additional values, which are just hex strings, hex encoded strings padded to 32 bytes of these two numbers here. And these are different for different attestation types and sources. But if you want to know more about this, go look at the guides on the Developer Hub website. If you're going to be using the JSON API attestation type, all you really need to modify are the three values under the request data, and then the contract in itself, your contract, the contract that you will be deploying. Anyways, I've talked for quite a while, and we haven't even reached the second step. But that one is quite easy. We use just generic function that, first of all, gets the FDC hub contract. It calculates the fee for our request, which is currently the same for all attestation requests, but it's prone to change in the future. And then we call the request attestation function on the FDC hub contract, and we also pay the necessary request fee. And that will start the whole process up. And afterwards, we just calculate the round ID of the voting round in which the transaction took place, which isn't that important right now. You clearly, I mean, you won't be changing this contract in your projects because it's very Flare specific. So let's not get into that because we're running short on time as is. Anyways, once the whole thing, so once we have submitted the attestation request, we can retrieve the data proof, which is mostly the same for all attestation types. Just the URL is different. And if we look at the base function, it gets another of the Flare's contracts, which tells us whether the round has finalized. And if it has, it waits for 30 seconds. 30 seconds is an arbitrary number that I chose. It's very high because I've been getting rate limited recently. Anyways, once the round has finalized, it prepares the proof request, which you can see, or rather you can see how that one looks like if you go to the Coston2 DA layer URL and again append API, and if you scroll to FDC request proof by request round raw and try it out, you can see that all we really need is the voting round ID and the request bytes, and it returns us the correct thing or our data. So next thing is we deploy our contract, we remember what address it is that, but more interesting thing is interacting with the contract. So once we get the proof from the DA layer server, we can decode it to an appropriate type, which is iJSON API response struct in Solidity, and we are getting the signature for that from the artifacts file. So this is basically a hack here. But luckily, you don't have to change this in your project. Anyways, with that, we can do the parameter, create a proof struct, which just takes a Merkle proof, which is already provided as this, and the decode response, and then we call our add character function on that input. And that's it. So let's just quickly run this script. We can, right at the top, there's a line of a comment that shows you how you can run the script. And if I just input that into the terminal, cool. So first of all, this is the attestation request. This is what we are serving to the what this we are sending to the verifier server. We can see that the response we get is okay, and this is the ABI encoded request. And now we submit this to the FDC hub contract, and we can see that the vote round number is ends with 488, and if we follow the link here, we can see how the round is progressing. Currently, there are no signatures yet. I'll explain what that is in a second. But I think that this is our request here. What we can do in the meantime is go under advanced and finalizations. And there you can see whether the round has been finalized or not. And in our case, it hasn't. We're waiting for the 488. But all the data providers claim that they can retrieve the data and generate a proof. this is what the green dots here mean. And the round hasn't finalized yet. So let me just take a sip of water. I will wait. Okay, so we can see that our round has finalized. And our code will trigger in a second here as well. The two numbers you can see here is the voting. Okay, cool. That's fun. Cool. Yeah. Well, this is great. This actually allows us to see how we can manipulate the code further. Let's see, we can just comment all of this out real fast, then paste those two here. Okay, I copied the wrong one, it doesn't matter. All I need is the round ID. And let's also do that real fast. Okay, that. And the round ID was this one here. I'm basically just running the script from that point forward, so that we don't have to wait for the whole thing to happen. So yeah, this is the proof request that we are sending to the DA layer. And this is what we get back. The response hex is the API encoding of the iJSON API response struct. So that's what we need to decode, and these are all the proofs. We can see that our contract has been deployed to this address here, which I will copy real quick. And we have submitted the data to the contract. It has validated the proof, which should be written somewhere up there. And the character that we retrieve is R2D2 with a BMI of 34. And they appear in 6 films. The last thing I want to show you is how you can add additional characters to your contract once it has been deployed. And to do that, let me comment out these 2 lines. What I will need to do is to get our character list as a Star Wars character list at the address that I have copied earlier. And of course, in your contracts, you won't be doing it this way, but it's just a fast way to show this to you. Let's delete these 2. Or no, let's comment them out so I don't regret that later. And uncomment this. And the character that we'll be trying to get is the character number 13, which I actually don't remember which one it is. But let's run the script again. And I will let that run while I answer your questions. So if you have any questions, let's just ask them now. So first of all, Sinachi, as I said, you can get the JQ Verifier API key from us if you just write into the Discord channel or the Telegram group. Although I don't think it's actually, or it might be necessary. I'll consult my team after this is over. But yeah, you can get it if you ask in the Discord channel. I don't have any on me at the moment. That's why I'm not giving it to you right now. Are there any more questions?
I think we did have someone typing, but they don't seem to be typing anymore. So that might be all the questions. Oh, no, they're typing again.
Yeah. I mean, typing takes time.
It does, especially to formulate your thoughts. No rush, we won't make you hit send before you're ready. Maybe while we're waiting, we do a quick shout out to tomorrow's workshop, which is going to be on connecting EVM chains and proving payment in arbitrary token on another chain. And we'll be seeing Nik again. It is at a different time to today's session. So make sure you check your calendar and come at the right time. Ooh, I think.
Yeah. It seems that we have a question. Let me just run the thing here while I answer the question. Majorly, we have to interact with the JSON API and base files. So the base files, or rather, you probably don't have to interact with the base file. Just the JSON API TypeScript file should be enough. These are templates that you can build upon. They provide a functionality already. There are other files for other attestation types, but if you're too eager and cannot wait until Monday, you can also look at the proof of reserves example, which has its own guide at the Developer Hub website. And this is an example of how you can actually use two different attestation types within the same dApp. It has several scripts, and I think that ideally you would break your project into several scripts as well. I hope this answers your question. Oh, you're typing? Yeah. Okay, cool. Let's wait for any more questions. Meanwhile, you can see that we have successfully added a second character to our list, which is Chewbacca, actually, with a lot lower BMI than R2-D2, it seems. There's another thing that I can show you while you're writing your questions, which is another way of getting or another way of seeing the contract, which is through the Explorer. So Explorer. Let's see. No, it would be the Flare Explorer. Sorry. Cool. So we can input our contract into the custom to